Hello, and welcome everybody to another webinar from Evers. Today we're gonna be learning an implementation that we did for a owner. Basically, we centralized data, implementing AI through the whole building lifecycle for this client. And today we're going to show how we did it and all the lessons learned we had, as it was a really long and hard process. AI sometimes sounds like something really nice to do, but um, data is the most important piece, and sometimes it's really hard to put together. So let's get going. So Evers, we're basically a group of architects, engineers, and software developers and geeks that develop solutions exclusively for the AC industry. We're based in Miami. Today is not a good day for Florida, but hopefully the weather is going to be much better. So we're around 30 employees, and we have mainly projects in the US, Europe, Latin America, and Australia. And most stuff we do is related with data centralization, digital construction, and design automation. So let me move this a little bit. All right. So the process is going to be on the process that we're going to show is going to be that how we created data warehouse for maintenance, then going to create a data warehouse for the whole company, not just maintenance, and then improving the building life cycle, and finally improving the process using AI. This is how things were in this project, and this is how we're going to show it. So, to give a little bit of background on facility management, let's give a little bit of background on the current state of FM. So when we consider building operations, we just take into account a building, trying to maintain the building as cheap and efficient as possible for the people living on the building or using the building in some sort of way. And we consider this sometimes when we consider digital twins, we consider this as digital representation of a physical building, right? So basically, how the user interacts and that data fits the digital twin, and that the digital twin reflects the physical building. But the reality is far from that. Nowadays, so many things are being called the digital twin. So, and sometimes even if it's just a 3D model of a building, that's already enough to call it a digital twin, and that's not the reality. So just to clarify, not even a BIM model is a digital twin. If we are going to be strict about it. So a BIM model is just a static data, and it's following as built conditions. The digital twin, in contrast of the BIM model, has live data. So, for example, how many people are currently on the building, the status of all the services, environmental conditions, etc. So it's much more than just the 3D geometrical representation of a building. And then if we want to get deeper into this concept, is digital twin is not only for, in contrast of a BIM model, which you basically use it mostly for the concept design phase and construction, but then digital twin is mostly used on the operation and maintenance and on end of a life of the building, where you can do like predictive maintenance, real-time operation, etc. And if we can see, like, this is just a chart I got from Google Analytics and on the digital twin world, and the hype, it's going up and up every year. And even the Gartner hype cycle told us that in 2018 we were a little bit early with digital twins. The technology was not there; it was mostly hype. And nowadays, we're starting to get into the slope of enlightenment and the plateau of productivity where you can actually get the real benefits of an actual digital twin in the AC. This can also be seen in the digital twin maturity continuum. That I love it. That it shows what for me is going to be the digital twin in a couple of years, where like it's just going to be like an autonomous thing that is going to take decisions, and there's not going to be even a facility manager doing everything. But then let's go to the ideal scenario. Enough of background. Typically, the ideal scenario would be you take data from pre-design to construction, and then you gather all that data, and then you do the handover for the facility manager or for operations, and then you use that data efficiently. And as I like examples, this is a project that I worked on a couple of years ago. Really large casino in Vegas that cost $4.3 billion. It had more than 3,500 rooms, more than 10 square feet, and remember on the side at the time were more than 16,000 workers. So it was a massive thing, huge. That we were excited because we were gonna do the FM process of taking all the data from pre-design to design to construction, and then hand it over really well done to the facility manager. And we were excited. Like I work on this like a really long time. The idea was to gather like all the as-builds, like everything to the detail. I remember that we were even updating the BIM models because there were changes in the field that were not following the BIM models as the construction was in a rush. Like many times happens. It's a bad practice, but it did happen. So we did the as builds for the BIM models. We followed COVID standards of all, like so many spreadsheets with all the data, all the drawings, all the models, everything was laid out. And remember, this project was huge. So we had more than, I think at one point it was more than 500 models, like BIM models. So it was a lot of work to do this. And this is a picture of me on the site at the time. And I wish I could hug myself because I didn't know what was coming. So what was coming was that the project hired a director of maintenance and operations. And at the time, for me, it looked like this guy. So evil and mischievous. The problem was that we made a huge mistake. We were thinking, you know what, we're going to take the pre-design, the design, the construction, everything to operations, but never happened. When we had all this huge amount of information and we wanted to do the handover to the facility manager's guy, he was like, you know what, I don't need it, I don't want it. I'm going to use this software. I don't remember the name. I think it was Red Sauce. I'm going to use a software that we don't use 2D drawings. We don't use BIM models. So we don't use copy at all. We don't care about all that. So we're not gonna need it. And for me, it was devastating. Imagine having to work for years on putting together data that then it was not gonna be used. So it was insane. So first lesson learned is you always want the facility manager guy to be as early as possible on the process. You cannot define a strategy on FM if you don't have your, facility manager's guy early in the process. Otherwise, it can happen what happened to us. So the problem was that there was no integration because the cost of implementation for the facility manager's guy was too high. There were no standards on how to input that data into the software. Like everybody does it a different way. Even when there is COBie or safety standards, the reality is not like that. Like skills of people who were going to supposed to manage these big models, and data privacy was also a concern. And I think that I wanted to draw a red line where they're really, all of these are great tools, but there are large platforms like IBM Maximo or SAP or Red Sauce, or like really well used platforms. That the problem was that basically they don't connect well with platforms like Ubeam or Tandem, Autodesk Tandem, or Aside or Cupix, that they truly manage BIM models. They're able to manage 3D stuff and beam data, in contrast to these players. Like these guys have exporters that can even go directly from Revit into or Navisworks into their platforms, but these guys don't, and they don't speak well to each other. So there is a big gap here that we need to solve. Um, and the traditional approach is that on every project you lose so much data. So you lose a lot of efficiency on each project. So for me, the building life cycle was a lie at the time, and I was not believing on that. But there were new opportunities ahead, and I was happy about it. We got a new client, and this is a client that we're going to speak about today, which basically presented us a much smaller opportunity. This was a much smaller building in Maryland. Basically, it was just a 40 million building. It was not that big, 150 apartments, 305,000 square feet, and 200 workers. So it was much more smaller thing, but the opportunity was huge, because now it was not only about integrating data from a specific project into FM, but the client wanted to basically integrate the whole data of the whole company. There were owners, developers, and they wanted to integrate the whole thing to operations. So they wanted to do this for all of their projects, and they wanted to centralize that in a single source of truth, a data warehouse. So there we was, me getting ready to make the same bad choice, but also being much more prepared than than last time it backfired. So life gave me a second chance to amend my mistake. So so we don't want it to get this again. So like, hey, great idea, but we have always done it this way. So we decided, why not we do a process that we keep the process as they are, but we improve with other tools. So we don't make, or we don't have to tell the facility managers or the operators or anybody to change the way they're working. um, so we divided this into three. So it was current project, future projects, and company operations. We wanted to improve these three things. So basically, current project, to analyze and get data on the current project and get benefits from the data on the current projects. Uh, Also, want to start a project in the future, I want to get historical data. I want to get improvements to future projects as well. And then also the client, and it was not the intent at the beginning, but we ended up doing it anyway. They wanted to improve their own operations, and it was not only construction, but they wanted to improve everything, sales, marketing. So we want to basically relate and integrate all the data. So it was really fun. Um, so basically, we also divided on the software that they were already using. So the idea was they were using Procore, Autodesk Construction Cloud, and Primavera. This was for past projects. I mean, for projects that have already happened, because they're already built. That's why you use these tools. The present, so basically how you can improve the way of the management of your current buildings. And then they were already using tools like Yardi or COSAR or Argus Enterprise to manage their portfolios, and also try to get more projects on sales in the future. So it was a big challenge how to integrate the whole ecosystem. So and they were using IBM Maximo for the management. The idea was to keep it that way. We were not going to make it the same mistake as I make on the first project, trying to impose a new tool. So we were we knew that we had to keep IBM Maximo. So the first thing we did was we started defining how the process was going to work. So the idea was to take multiple sources of the different platforms or the client owned, send it to a data warehouse, and then create some sort of reports for them to analyze the data. So that was just the beginning. Then we started defining what was going to be the architecture of how we're going to treat the data. So you have two different ways of treating the data. So you can extract data from a source, let's say Autodesk 360 or BIM 360 or Autodesk Construction Cloud. Sorry, I missed the names there. And you can extract the data, you can transform it. So for example, if there is certain data you don't want, for example, I'm extracting data from Autodesk Construction Cloud, but I don't want I don't know, certain parameters on a BIM model. I can remove that data and then send it to a data warehouse. So that's called ETL. So extract, transform, and load. And then the other option you have is extract everything, just the raw data. You don't care about processing. Extract everything, load it into your at the warehouse, and then transform it. And we went for the second option because for us it was much better because like ELT, first of all, it's much more faster to send the data. Sure, it takes much more space because you're not pre-processing, you're storaging everything. So we decided to do it anyway. Like storaging nowadays is not that expensive when we're speaking about this scale, so it was not a problem for us. The processing, the complexity is this is much more easier because you already have the data, so you can do as many processes as you want or make mistakes. You don't care because you're always going to keep your data. On the other one, if you make mistakes, you might regret it in the future because you might lose data that you cannot go back to look for it. Then sending data to directly to the data warehouse is much faster because you have to pre-process it. And then it's more flexible because then I can send data and structure it in multiple ways. Here, I'm more limited because of the amount of data. So then what we decided is like, all right, let's send everything to the data warehouse, process it in some sort of way, and then make queries, specifically endpoints of the API that I can query with Power BI or any type of reporting tool. Things started getting a little bit more complicated. So we decided, all right, we were going to use some sort of report like Power BI or Looker. We were going to use an API for suggestions. So, for example, if you could use ChatGPT or something to ask questions, and then alerts of notifications of emails automatically, like, hey, the cost of something is exceeding the budget, or you have an emergency on the operations side and something has happened, send an email. So these were the three strategies that we were considering for the process as an output. And then we just did a matrix on how often we're gonna do this and the scale. So basically, for example, reports, we were gonna send weekly progress reports through Power BI, for example. We didn't need a report for future projects, but the company wanted to get, for example, financials as reports. Suggestions, we wanted to, for current projects, design subcontractor materials, for example, stuff like that, and get reports for that. Major setbacks, where to invest, and alerts on major costs or major delays, whether are at company level or current project level. So these were all approximations. At the beginning, it's hard when you're putting together a strategy like this because you don't know what you need until you get your hands dirty and know how much data you're going to be dealing with. So we divided on these three outputs: so reports, suggestions, and alerts. And then the problem was that one does not simply use a single software for everything. That never happens on any company. So that was a big challenge for us because they were using so many tools. Like on the construction side, they were using Procore, Primavera. On the marketing side, they were using HubSpots on Mailchimp. On the accounting side, they were using QuickBooks. On the real estate side, they were using Yardi, and sales, they were using LinkedIn, design. There were so many different tools on so many areas that we needed to connect, and that's a challenge. But we defined all the sources we had, and then we selected a database that was flexible enough to handle all that, and that you could handle new sources in the future. We had 4 options. So this is Google, this is Amazon, this is Microsoft, and Snowflake. We ended up going for BigQuery because the client was already using Google as their infrastructure. So we decided using BigQuery, and it was a good idea because we ended up being really efficient. So yeah, we decided to use BigQuery. And then the problem was how on earth we were gonna connect all these sources, all the sources you might have in your project in the future with data, with a database. In our case, BigQuery. So in this case, we decided to use different strategies. We use Fivetran and Zapier are services online that do this automatically for you. So basically, you select the source and then you select destination, and you can tell them how often do you want all the data to be automated. You don't need to almost have any knowledge of programming. It's just setting up the permissions, and then how often do you want the data, and that's it. It's pretty simple. In some cases, Fivetran, we wanted to use Fivetran for everything, but Fivetran, I think they have more than hundreds and hundreds of connectors, but there are thousands of platforms out there. So they didn't have the LinkedIn and Yardi connectors, so we had to use Zapier for that. So that was the thing. And then for Procore and Oracle, they were not good solutions. Neither Fivetran nor Zapier were really good, to be honest. Like, it was really limited. You could only extract a really small piece of data. So what we ended up doing is we ended up creating our own connectors on a Google function. It's a little bit harder because you have to code stuff to connect both things, but we didn't have any other option. That happens sometimes. So the process ended up being something like this, where we already have our sources, how we're going to connect to data warehouse, the process, and then the output. And then we needed to select a reporting tool. In our case, we ended up going for Looker, to be honest. Oh, sorry. We ended up going for Looker because, again, the client was already using Google. Our favorite was Power BI. But I don't know, given the fact that we were integrating so many platforms, we wanted to, for us, it was really important to try to put everything together on the same infrastructure. And by the way, Looker is not that bad. It's not as powerful as Power BI or Tableau, but it's pretty decent. So then we wanted to select how we can give suggestions to the users based on the data, how the user is going to communicate to the data that it's on the data warehouse, right? Not reports, but being able to also ask questions. So a couple of ideas for us was to basically open the door to a chatbot, or actually a website that you could go and ask questions like, hey, what's the efficiency that we have gotten on the past 10 projects, for example. So that was our idea. And then to create alerts, given the fact that the user was already working with Google and MailChimp, what we did is the user had to define rules of the alerts on an Excel spreadsheet. So for example, hey, I want an alert on a building every time there is certain cost or certain delay or certain something. So you define the predefined rules on Excel spreadsheet. We used to read those rules like a couple of times every hour. And then if something happened, we submitted an alert to MailChimp, which will send an email to everybody that was involved on the project. For example, if there was a notify that the cost or the impact was uh, big, it was an important RFI, they will get, for example, emails. Or if the number of RFIs on a project is too large, they will get emails. Like there were so many predefined law rules. So that was the idea, to allow, um, users to be able to predefine rules. So the thing ended up being like this. There were 3 outputs, like we said. Something like cloud endpoints where we can use as a chatbot, the reports on Looker, and alerts that were going to be sent through an email. So that's it. We had the the plan for it, and it sounds super easy, right? Well, it was not, but we did it anyway. So this is how we structure it on the data warehouse. So basically, you create sections for each of the different softwares. So basically, under Beam 360, Bamboo, HubSpot, IBM Maximo, we created a section with tables inside it, multiple tables inside it. So that was the first thing, defining the structure that we were going to use for the data warehouse. In this case, for example, I think this comes from Procore. Yeah, it comes from Procore. So basically, you we created this is the API of Procore, and these are endpoints. So each one of these will give you different data. So for example, this will give you the budget, and then details on the budget, filters, columns. So what we did is we did a 1-to-1 match, where every 24 hours we will update each of these endpoints, and each of these endpoints will go send the raw data into tables on the data warehouse. Um, and then what we did was we created fields. This is just one endpoint, which will give you some specific information. In this case, the biller, who sent a bill, for example, the contract number, the cost code, the cost type, the description, the ID. So each of these fields that were coming from the different endpoints on the Procore API, we created one field per table. So it was a big work to do this mapping. So it was 18 sources, 18 different platforms. We ended up having 140 tables, which was huge, and then 70,000 rows. So it was a massive effort to get the initial data. And we wanted to create stuff like this. These were the type of reports that the company were imagining. But the problem to basically create those kind of reports that look really good is that you need to define a strategy on what to measure and how to measure it. And that's also really tough, because you can have the data, but then doing that stuff. So we held more than 100 meetings with different stakeholders in the company. And yes, we repeated many meetings with many stakeholders. And we refined that, and we ended up with 160 dashboards for the whole company. Spoiler alert, this was a huge mistake. When you ask people, hey, how many reports you want? It's like free t-shirts. They will get as many as they can, or free food. They will get as many as they can. You need to basically start really small, and then actually see how they're using the dashboards, and then increasingly add more. The problem is that we created 160 dashboards, and after we implemented this, after months, they were using only 20% of the dashboards. That's nothing compared to all the effort we put there. So it is important that you never ask people that and you implement everything, but actually implement really small, or a couple that they need, that are critical. Then if they really need more, and you see the ones they have are being used, then you can increase the number of dashboards and invest the time that it requires. Um, so then when we started what doing queries, queries to the database to create reports, we thought that there were different complexities of queries to actually access the data warehouse. So the first one was going to be a simple query. So basically, I'm accessing uh, a table from Procore, let's say. So it was just one single table, one single thing. So a complex query for us, if we have to basically integrate data from multiple tables, so multiple tables from Procore. And then the last one, which is much more complex, is relationship query, where you have multiple tables from multiple sources. So, for example, if I have a project in Autodesk Construction Cloud, a project on Procore, I need to find a way to tell my report that this project is the same project as this one. So there needs to be an ID or something that makes the connection. So and this is much more complex. So we defined it on these three levels of difficulties when we started implementing it. Um, so this is a good example. Like I said, Procore and take the RFIs table. Uh, I take multiple tables from Procore. It's a little bit more complex. But then if I'm integrating multiple sources, it's much more complex. For example, I'm getting all the RFIs from a project by subcontractor and then get the feedback from the HR platform that we're using. So how do you match the data? This is the thing. What happens is you have a great data schema, but each platform, but each platform is a data silo, right? And that's a problem. So I think my image. Um, and then so basically, you what you do is you need to decide how you're gonna match the different elements on the project, right? So in this case, what we decided is you could match by name. For example, if two projects are called the same name, that means it's gonna be the same project, right? But that's not the case. That could lead to many mistakes because names can be repeated. So we decided to go with IDs, how we can match different projects integrated by a single ID that could go through all the platforms. And that's also a problem because you either have two different options. You manually replicate an ID, for example, project number one, and then you define on each table, hey, this is project number one, this is project number one, this is project number one. Or you define a way to automatically create relationships between all the different platforms. One takes more time, the other one is harder to implement. So the way that this was going to work is we will define an order in which projects and entities were created. So, for example, if I created a subcontractor entity and I want to register a subcontractor, the Procore entity needs to be created first. Then the subcontractor will be replicated into Primavera. And then after being replicated in Primavera, it's going to be replicated in QuickBooks. That way, I can be sure that when I'm replicating, I'm moving also the ID. So then there is a connection. There is a line that connects, a thread that connects all the different platforms, and I can make analysis of multiple sources of data together. So after all that, this looks something like this. Every time when you send something into the data warehouse, you need to replicate with a function. This is a custom function in Google that replicates into other platforms. For example, if you create something in Procore, and then that needs to be replicated into, for example, Autodesk Construction Cloud, or the other way around, you create first the project on Autodesk Construction Cloud, and that triggers the automation that if the project doesn't exist on Procore, it will automatically create the project on Procore. And it was interesting because this automation saved a lot of time to the client, not only because we need it, but But the reality is that we ended up patching 15% of the data manually or partially manual. Like when you're migrating data, one thing is when you have clear standards and you're prepared for it, and the other thing is when you have never done this and each platform has different standards or each project has different standards. So standardizing all the data, it's hard. And there were, to be honest, there were projects that it was so hard and they were so old that we didn't even end up putting those on the data warehouse. It was like, you know what, if projects are older than 10 years or 5 years, let's not do anything. And then after that, after the current moment, every project is going to be added to the data warehouse. But past projects, it was hard. Um, so yeah, and these are the type of different areas of the company that we're basically taking all the different data, and this is how the data warehouse looks under the hood. But initially, we were not considering all these areas, but we ended up getting data from construction, real estate, marketing, accounting, sales, HR, management, and design. So it was also tough to adjust something in between. And there's a couple of dashboards that were created out of our tool where you could get revenues per building, gross margin analysis. This is all financials and quotes on sales, on how many quotes are you having and how successful are you being on that. So yeah, it was interesting. And then we were able to actually do stuff like construction time prediction. Like you can never be exactly accurate, but it was possible getting predictive maintenance modeling, investment return of analysis, knowing like, hey, you know what? Let's not invest anymore on Florida, on this specific city, this type of buildings, because right now the market is not ideal, and save time on the analysis time that return of investment was going to get on each of the projects. Optimize price models, fertility utilization analysis, and customer segmentation and targeting. Um, I know this sounds all really complex because it's simple to send data to a data warehouse and then extract that data and create dashboards. It's not that hard. Once you define what you want to visualize, it's not that hard. But when you need to start making calculations on all the stuff, for example, on that I previously showed you, that's a different story. It gets much, much more complex. And in that case, what we decided to do is, and to be honest, we didn't know it was possible up to this point, but BigQuery has a really, really great integration with Google Colab. Google Colab are these type of pages where you can script code really fast and bring external libraries. So what we decided doing was that for complex calculations, we were going to use this Google Colab and then use libraries like PyTorch, Keras, etc. Like these are machine learning libraries to analyze this. And the fact this sounds really complex, but the reality was it was not hard. It was not hard, to be honest, because the integration is so great that you can really quickly calculate things. And then we ended up having something like this, where instead of just looking really basic data on Looker Studio, we will use Google Colab to process it using machine learning and then send the outputs to Looker Studio. And yeah, we could do stuff like that, like how type of sales that we were getting, and create graphs that were much more complex than just simple regular data. And then, well, we centralized most of the data. At this point, we already replicated data between platforms, which was really good. We analyzed patterns and KPIs. So C-level was really happy with us. And then data logic data logic that tied in every single element to the whole life cycle. We could know when each of the elements appear, who decided on each of the elements. So we have traceability of basically, I would not say every element, but most elements. But at this point, this was our client. He was not happy enough. He wanted more out of the process, and and the thing was, he wanted to analyze data in much more complex ways. He didn't put it like that. He just wanted the output. But then when we started analyzing how we were going to basically get that data, uh, we divided also in three different ways of analyze this. So asset-based data was, hey, this table, it's located on this room, that this room is located on this uh, building. And so we could do child, parent, parent, parent. Hierarchical, we could know the same. We could know, hey, these are multiple towers that are located within this project. What's the hierarchy here? And then topological, what's the relationship between one room to the other? It's not only, hey, all these rooms are located within this specific level or office, whatever. But we also needed to understand, like, if the patterns of how people were behaving on this type of buildings, we needed to understand if one room was located to the other. So if people were going a lot through a room, how was that affecting the office next to it, for example, or why they were not using certain bathroom, for example? I don't know. So we needed to analyze data on three different ways. Um, and the problem is, we for this we decided to analyze actually the formats that are out there in the market. And the thing is, like, even when the IFC, for example, is topological and it's really good, it was not really good in terms of the 3D quality of the format itself. And we didn't care about the format, to be honest. We just wanted a way to send quickly and efficiently data and analyze data from one place to the other. So the thing is, like, we decided to end up creating our own schema. And the reality is that even when there are formats like IFC, and for users, it ends up being that way. Like, hey, export it and use IFC from Revit into Rhino. I don't know. But when you are an owner of a platform, more, in my experience, most AEC startups end up creating their own schema. It's something custom that you don't see under the hood, and they might not even export a model or data on that specific format, but they're using their own schema. So that's what we did. We decided to create our own schema, where we could have relationships between, for example, a company who's a real investor, the deal, where it's located, the project, where is the stage of the project, the building, a level, category, element. So we could go on the hierarchy and ask questions of, hey, what company is working on this specific element, right? We could jump, given the fact that we could have the relationship of the whole tree, we could easily analyze data on multiple levels, which was really interesting. And yeah, piece of a schema, for example, for buildings was something like this: project, building, model, then model, levels, elements, etc. And this, I love this example because this is a Revit API object model, and this is how the structure of Revit works, for example. And they created their own schema, right? The relationship between parts, and that's kind of what we do as well. You don't have any option but doing that. And then this was the hardest part: how to tie data through multiple platforms. This was the defining the logic on how, again, how is we're going to go from company to client to project to architect to contract to model to element, and how we are going to automate that data gets replicated between all of them. Uh, and again, um, that was something that we also added, that if an entity was not being able was not uh, being created correctly. So, for example, if somebody wanted to actually create first a building and the building didn't have a project, because you could still do that. You could just go manually go to Procore and create something, and you don't have the deal, for example, for that specific project. Or you could create the subcontractor entity, but you don't have a building. That's a mistake and that's an error. So that's also something that we analyze every hour. And if an entity was created wrong, we'll just get a notification through email or through Slack, which is the software messaging software the owner was using, to let them know, you know what, someone has created this entity wrong, and you have to go there and fix it. So that was also hard. So yeah, that something like this would happen if you create a new deal and there was a problem. This is Slack, and it will tell you, you know what, there was an error processing a request. So they could even get some for deals, for example, they could get live data. So if something is happening, uh, well, bad on the data, you could get this error. And this must sound like a nightmare. And at the beginning, it was, to be honest, because people were getting errors all the time. But this is a good way of defining processes and standards, you know? Once people get used to it and learn how to avoid the errors, all the data was being created on the same standardized way through the whole company. So when you get to that point, that's amazing. Uh, another problem we encountered was that we deployed everything, but IT of the owner was not completely happy with us. And the thing was that we needed to basically create permissions to different type of users. So for with that, what we also did is, given the fact that we're already using Google, and when you have Google users, you can easily define who has permissions to access certain dashboards, or you can manually do it really fast by groups. So, for example, you can define, hey, all the links that are on the finance are emails that are these type of users that are going to be able to access these type of dashboards. So to complying with IT, we use this. So IT didn't have to do anything. We just tied in all the different dashboards and permission and endpoints to the groups that were already created by IT. So it was not big work, but we added that extra layer of security that um, yeah, allows us to for the client to be happy. So this is how we did it. Like we added a layer on top of the Looker Studio, um, and it was simple. It was simple and it worked. And then what we also struggled a lot was adding all the IoT layers. So something that we need to decide is that we're going to connect all the IoT devices directly to Maximo, and then from Maximo send it to our data warehouse. But we decided we didn't go that path. Every IoT device was going to send all the data to the data warehouse. IBM Maximo was going to send it to us, and then we will process it. We will have more control on doing it this way, and ended up doing the same way. We use a service called Google Pops Hub. This is a service created by Google to actually integrate with many IoT devices. So we took all these type of like sensors, alarm, card readers. It's just a couple of examples. Send it through Google Pops Hub, and then send it to our data warehouse. We did the same with environmental data, which is something that most owners don't do, but we get data from open weather on solar data, wind, humidity, temperature, precipitation, and air quality on each of our facilities. Not only because we could act if I don't know, there is a hurricane like now in Florida, or in cases that you want to analyze how the maintenance needs to happen based on the type of weather that you're getting. So OpenWare was, we use the free part of it, and then for traffic and security we use Google Maps and SafeGraph. Again, the cost was almost zero, so that was also really good because we had to make a lot of queries to actually integrate that piece of information. And then and I love this kind of graph. This is the this is a ratio that is getting famous because there are pizza places around the Pentagon, and when these pizza places get crowded in certain times of the day, it means that something is going to happen, like a war or something in some part of the world. And I feel this is amazing, and I want to bring this as an analogy on how you can start bringing data that has nothing to do in common, nothing, pizza places and the Pentagon, to understand if something that's not related as well, like a war, is going to happen or not. So it's really interesting, and that's something that we took in mind for our project, to be able, to how we can get that extra data. And some of the cases we did was, we told the users, when steel members were more expensive, like, hey, you're gonna have to import this from China or something like that. Why do you get a slightly larger or different section of steel and save 10% on steel? Subcontractor failing on handover. Like, hey, this subcontractor is making the same mistake on every project. Be careful. Like, he might make the same mistake on this project. So historical data was really powerful for the owner in this case, and the GC as well. And maintenance not being done properly also. That's something that we discovered, that it was not a problem of the equipments that were installed, but sometimes it was maintenance that was not being done properly. And then the last piece was the integration with the chatbot. So people could actually ask questions. The only problem with this was the cost. So we decided to use OpenAI. The problem with ChatGPT is that ChatGPT is a closed model, so you cannot add extra data. You can, for example, you can send data every time you make a question. So, for example, if I want to ask a question on, let's say, a book, is going to send the book every time I want to ask the question. It's going to charge me for that. And the problem is that the cost tokens that you need to pay to charge for ChatGPT to do something like this, first of all, it's hard to know how much it's going to be. For example, like the words with the same length might have the same cost, or shorter words might have bigger cost. These are examples of, I love it, that for example, FFF, if you send to the that to ChatGPT, it costs one token. But if you send PPP, it's two tokens, and QQQ is three tokens. And this varies because it's how often this combination is used in our language. It's based on that. Yeah. So you can never know how much it's going to be. That's first, and then the cost can be a lot. For example, if you send an IFC with 5,000 words, it's going to cost you a dollar every time you make a question to that specific IFC. If you send the largest the largest book in the world by Marcel Proust, is gonna charge you $24. $24 every time you make a question. For Harry Potter, all the books, 7,000 words, it was just $1 $20.53. But for our data warehouse, that it was more than 180 million words, we're gonna pay $3,600. That's insane. There was no way we could basically send data, OpenAI or data warehouse every time we were going to make a question. So and we didn't to be something like Dory that forget, um, because that's the thing. ChatGPT forgets. So we ended up doing something different. So basically, we on BigQuery we use a database schema, and what we did is we told OpenAI, "Hey, this is a schema. This is the structure of the data warehouse, which is really small. The structure of is really small." And then we could tell OpenAI, you know what? If you want to get specific data, tell us a query, give us a piece of code that we can re-inject into our data warehouse, and then only use that data. That way, we could shrink a lot the cost of what we needed. Instead of just sending the whole data warehouse, OpenAI itself will tell us what specific fields, tables, and sections of the data warehouse it needs. Um, and that was a fancy solution that helped us create a chatbot that had a filter through OpenAI to actually make questions that way. Um, then we decided to also use ChatGPT to send weekly reports. Same thing. We applied the same concept, and we use Slack for that. So we create a function and use Slack for that. But something that we did is we ask ChatGPT, is this is just an example. If life is a simulation, this was like 8 months ago. Maybe it's better now. And every time we ask that question, we have different answers. Sometimes it was like, I don't know, maybe. Sometimes it was like, yeah. And the problem is, how do you respond to answers to users if you don't have consistent answers? And that was the second problem we need to do after we implemented our chatbot. And the other problem is that sometimes it gets errors. 4% of the times it gets hallucinations. I think this is better now, but 6 months ago it was something like that. The intent sometimes is like, again, it can be positive, uncertain, or negative. It can vary. So 90% of the time, the variation changes when using OpenAI. So what we ended up doing was adding a second database that will storage answers that our users like. So instead of re-asking again, it will just preload the answers that were already fit into ChatGPT. So, for example, if you like how ChatGPT calculated a return of investment, you will just hit click, and that will be saved onto the data warehouse. So next time ChatGPT, instead of trying to provide the same answer, will first go to the data warehouse. If there is an answer, it will use that answer, and then if there is no answer, try to provide one. So as listeners and finalizing this webinar, we improve process. These are the good things. We generated standards. All the data silos were removed, and efficiency was improved on not only on the construction side and planning side of the owner, but also on the operations of the company itself. The bad part was that data is never perfect. It never is. A lot of maintenance is needed for this. It's not that you created data warehouse and that's it. Endpoints get updated on APIs all the time, and things get broken all the time. You need maintenance to keep everything tidy. So a lot of maintenance is needed. Again, also, like I said, API changes. So if Autodesk is changing their API, it's a problem. You cannot keep using it. A lot of adjustments needs to be done all the time because priority changes. So you might need a person that's advocated just for this after you implement it. But I feel the return of investment on this case was much harder than that. And as conclusions, centralizing your data is a must no matter the company. This is a huge scale, but you need to start now if you're not centralizing data in your company. Start small, always start small, and then think big. Hey, the output, the idea, the end goal is to make something big, but always start small. First, understand the problem, then define the solution, and then select the tool. We did it that way. Hey, what was the problem? What do you want to measure? How are we going to solve it? And that's how we define it, all the different outputs, and then define the tool, the right tool for it. It's not like, hey, AI works for everything. That's not the case. It's just another tool. You need to make sure it's actually worth it. And then, thank you very much for listening, and I hope you enjoyed this webinar as much as I did. This is my information, and my name is Valentin Nopes. I'm the CEO at Evers. Hope you enjoyed this. If you want to check more information on Evers, you can check our website, www.evers.com -learn. Also, if you have any burning questions, we will do our best to answer them. And thanks so much for your time. Hope you enjoy your afternoon. Thank you. If you have any questions, send us our way.